Okay, so right before spring break, we looked at the beginning of Unit 9, which has two parts. The first part is right triangle trig, and then the second part is newer things like angles and the unit circle. So because we were still in third quarter, I didn't teach the full lesson for 9.1 because I wanted everything to count for this quarter. So all we did last time was basically review right triangles. So, and talked about how to name our sides based off of a focus angle. Then the very last thing that we did was go over SOHCAHTOA. One thing to remember about SOHCAHTOA is that it only works for right triangles. So be careful about that. You're going to have one question in your quiz today that's online that's going to ask you if you can find the sine of a given angle. You can only do that for right triangles. So if you're doing anything SOHCAHTOA related, it has to be a right triangle. And then lastly, SOHCAHTOA is or are ratios. Given an angle, it's the ratio of a specific set of sides. So we did a practice problem on our cover page for this unit. Given triangle lengths, we found the ratios. And this, we're building on this today. So I think most of them don't need to be simplified today, which is good news. On the paper quiz that I had you practice, if you got ones wrong, most of the time it was just because you needed to simplify. So we're building on this today. So we need to start with the knowledge that this only works for right triangles and that everything that we're looking for ends up being a fraction or a ratio of side lengths. So we're going to start on page 107. So on 107, we reminded ourselves what SOHCAHTOA actually stands for. So SO is the sine function, and it means you put the opposite over the hypotenuse. You can see the one for cosine and the one for tangent. We're going to add some numbers to this triangle here so that we can do the new stuff that we're being asked to do today. Our focus angle for this particular triangle is right here. This is theta. So that means based off of this triangle, if I go across, this angle, if I go across from this angle, this is our opposite side. Across from the right angle is always your hypotenuse, which means our leftover one is our adjacent side. And notice it is one of the legs on our focus angle. So the new element that we're adding today that we did not discuss last time is that sometimes they're not going to give us all of our side lengths. So let's say the opposite side is 2 and the adjacent side is 3. Well, today a few of our problems are going to ask us to find the missing side before we can do our trig ratio. So way before now, we learned the Pythagorean theorem. So Pythagorean theorem says if you have a right triangle, you can do a squared plus b squared, and that is supposed to equal c squared. So hopefully that sounds vaguely familiar to you. This guy is the Pythagorean theorem. If I look over here, though, I don't have any little a's, b's, or c's. So let's translate it for the right triangles that we're working with. I'm going to call little a, I'm going to change that to the adjacent side. So we can say adjacent squared plus our opposite side squared equals our hypotenuse squared. So we're taking that Pythagorean theorem that hopefully we've seen several times and making it so that it matches our right triangle. Okay, well, we know adjacent side is 3, so we're going to say 3 squared. And opposite side is 2, so plus 2 squared. That's supposed to equal hypotenuse squared. You can just plug this into your calculator now if you wanted to, or you could solve it in your head by doing 3 squared is 9, 2 squared is 4, 9 plus 4 is 13. And then how do we get rid of that squared? What's our inverse operation? Somebody's got to know. Square root, very good. We've talked about that quite a few times this year. If we want to know what the hypotenuse is, instead of the hypotenuse squared, we take the root. Well, I know that 13 is not a perfect square. In fact, if I plug it into my calculator, it's an irrational number. So our hypotenuse is approximately 3.6. Our bottom is 2, our height is 3, and our hypotenuse is 3.6. But most of the time, they don't want us to estimate. They don't want us to write 3.6. They want us to write the exact value. So we would say that the hypotenuse is root 13. We wouldn't change it to its decimal. We would literally leave it as root 13. How you know to do that is because they'll say something along the lines of, find the exact value of the missing side. So if I go over here now and fill in my side length for the hypotenuse, we would leave it as root 13 when they say things like, find the exact length. So this is exact. An estimate would be 3.6. Now that we have all 3 side lengths, let's use this triangle here. So this guy. And let's find these 3 trig ratios together. So we're doing these 2 together. Remember, theta is this angle right here that they have marked. So this is our focus angle that's often referred to as angle theta. They want us to first identify the sine of theta. So what they're saying is, find the sine of this angle. Well, from last time, I know that that's the ratio of the opposite side over the hypotenuse. That's where this so comes from. So just for your reference, I'm going to write in O over H. You can skip that if you feel comfortable with these. My opposite side was 2. My hypotenuse is root 13, and we're just going to leave it as that, 2 over root 13. Cosine is ca, so the cosine of this angle theta is the ratio of the adjacent side, 3, over the hypotenuse, root 13. Then lastly, we have tangent, which is TOA. So based off of this angle, opposite is 2, adjacent is 3. The new element is finding your missing side. This part here is what we did last time. This was the little part that we started before the end of term. So today, the rest of our problems, the first part that we do is find the missing side length. Number 1 has the hypotenuse missing. So just like on the last triangle, the side that we're missing is H. I know that this side is H because it's across from the right angle. My angle of focus is the one that is labeled theta. So that's this guy right here. So I'm going to highlight him just to make it clear what I'm working with. So it's this angle that we name the other sides based off of. So if this is theta, that means across from it is your opposite side. So 5 has to be our adjacent side. They want us to find the 3 trigonometric ratios for this triangle. It's ABC. But in order to do that, we have to know the hypotenuse. So we can set that up exactly the same as we did right here. So for your reference, I'll write down that formula with the letters. A squared plus B squared. Oh, just kidding. O squared is hypotenuse squared. A is 5. Opposite is 12. This is one where it might be more helpful if you just plug in 5 squared plus 12 squared. So 5 squared plus 12 squared is 169. And I'm not 100% sure, so I'm going to double check using Desmos or a calculator if that's a perfect root. Because once the numbers start getting a little bit bigger, I don't know if they're perfect roots or not. So 169 is a perfect root. The root is 13. So the length of our hypotenuse is 13. So my adjacent side is 5, my opposite side is 12, and the hypotenuse, which is my longest side, is 13. You're hanging in? Okay, you're now finding the ratio of those sides. So given your trigonometric function, you find the ratio. So I have all my sides labeled. All you have to do is go over to the triangle and put O over H, A over H. So you guys try those without me. None of them need to be simplified. So like 20-ish seconds. Yes, dear. Sure. About 10. Five. Okay, your sine of theta is 12 over 13. Cosine is 5 over 13. Opposite is, just kidding, tangent is 12 over 5. Is that what you guys got? So in your Canvas quiz, when you have to enter in the ratio, you'll just do 12 backslash 13 for your fractions. Okay, so we've talked about how this only works for right triangles. We've talked about how to name our sides based off of a focus angle. We now know how to find a missing side length, so we're going to put that all together. So our last two problems combine everything that we've talked about. They start by giving us the tangent of an angle. This means the tangent of the focus angle is 3/4. They want us to find the sine and the cosine for that triangle. The issue is they have only given me two sides. They gave me tangent, which means they gave me TOA. They have given me the opposite side and the adjacent side, which means that I need to find the hypotenuse, and that's why we had to learn how to find that missing side. So I draw a triangle every single time, and I draw the same exact triangle. Whenever they give me a problem like 3 and 4, I draw this triangle because it helps me find the missing side. I know that this opposite my right angle is H, and if this is my triangle, it matches the one above it. So I know that the bottom is always adjacent and the left-hand side is always opposite. So if my triangle looks like this, I know that it's always AOH. That's why I draw this triangle every single time. You could have drawn this triangle and you'll get the same exact answer. Okay, so opposite was 3. Adjacent was 4. How do I know that? Right up here. They give me tangent, which is TOA. And just like in the last two problems, we're now going to use that to find hypotenuse. So we're going to say adjacent squared plus opposite squared is hypotenuse squared. And these numbers are little, so I can do them in my head. 4 squared is 16. 3 squared is 9. 16 plus 9 is 25. And hallelujah, that's one of the most famous perfect squares. What's the root of 25? 5. They want me to find the sine and the cosine of my focus angle. So this is my focus angle. We normally call him theta. They're calling it x. They're the same thing. Sine x and sine theta are the same thing. So we just need to put our opposite over our hypotenuse, which is 3/5. Cosine of x is just the same thing as cosine of theta. They just want us to find the adjacent over the hypotenuse. So this guy is 4/5. So that's as complicated as it gets today. They're going to give you a trigonometric ratio and expect you to find the other two. Now, number 4 is slightly different. So I'm going to set it up with you and then you'll find the ratios on your own. It's different because they give us sine. And sine is so, which means they have given me the opposite side length and the hypotenuse. So this is the first triangle where the missing side isn't the hypotenuse. I draw the triangle, even though for some of you guys it's probably not necessary. I always draw it. I have my opposite side is 1. My hypotenuse is 2. So my equation looks slightly different this time. This time we're going to have a squared plus 1 squared equals 2 squared. Well, we'll have a squared plus 1 equals 4. We can't have this plus 1, though, hanging out here. If we ultimately want to know what a is, we can't have a plus 1 hanging on. So how do we get rid of that plus 1? You just minus the 1. Hopefully y'all was just asleep and not that we didn't know that. A squared equals 3. And then our last step is the same step that we did on all of the others. Root. I know for sure root 3 is not a perfect square. So my adjacent side is root 3, and notice they say here, find the exact value. So we leave it as root 3. So you guys find cosine and tangent. You guys find cosine and tangent. Let's go about 10. Five. Okay, cosine would be root 3 over 2. And tangent would be 1 over root 3. Is that what you guys got? Okay, so the first several problems will ask you what is the adjacent side to this angle, or what is the opposite side to this angle. Then it'll have you do basic ratios, so it'll give you all 3 sides and you just need to give the ratio. And then the last 3 are ones like the bottom. You can handle this? Okay, give it a try. It should be published and ready to go.